the National Transportation Safety Board has now released its first official briefing on the fatal plane crash involving Greg Biffle near Statesville, North Carolina. And for the first time since this accident occurred, investigators have confirmed several key facts that move this case out of the early rumor stage and into a clearer factual framework. We now have confirmed information about how long this flight lasted, which runway the aircraft used, where the first impact occurred, what the weather actually was at the time, and what recorded data investigators were able to recover from the airplane. Some of this new information clears up earlier uncertainty. Other parts narrow the focus of the investigation in ways that raise more pointed questions about how this return attempt unraveled so quickly. So let's walk through what the NTSB has now confirmed, and why these details matter for understanding what investigators will be looking at next. The first thing the NTSB did in this briefing was lock down the facts that are no longer in dispute. There were 7 people on board the aircraft. There were no survivors. That number had varied in early reports, but it is now officially confirmed. This was a complete loss of everyone on board. The aircraft involved was a Cessna Citation 550, a light business jet manufactured in 1981. It was privately operated and registered to a leasing entity. From a certification standpoint, this is a mature aircraft design that has been in service for decades, and one that investigators are very familiar with. The total flight time from takeoff to impact was approximately 10 minutes. That matters more than it might sound like at first. This was not a prolonged flight where a problem developed slowly. Whatever prompted this return happened early, and the entire sequence unfolded very quickly. Investigators also confirmed the location and sequence of impact, and this is one of the most important clarifications from the briefing. The aircraft did not touch down on the runway and then lose control. It did not overrun the runway. It did not suffer a hard landing that collapsed into an accident. Instead, the aircraft struck terrain approximately 1,800 feet short of the runway threshold. The first point of impact was part of the approach lighting system. From there, the aircraft continued through trees, additional lighting structures, and the airport perimeter fence before coming to rest near the runway environment. A post-impact fire consumed much of the fuselage and portions of the wings. That sequence tells us something very specific. This was ground contact prior to touchdown. In other words, the airplane never made it to the runway. That distinction is important because it changes the type of accident investigators are dealing with. This is not about braking performance or runway conditions. This is about approach geometry, altitude, and whether the airplane was in a position from which a safe landing was still possible. All 4 corners of the aircraft and all primary flight control surfaces were located in the wreckage, and both engines were found with the main wreckage. That tells investigators they have a largely complete airframe to examine, which is critical in the early stages. With those baseline facts now established, the next question becomes more focused. How exactly did this return attempt unfold in the final moments of the flight? One of the biggest clarifications from the NTSB briefing involves runway usage, and this matters because it removes an entire layer of speculation that existed early on. Investigators now confirm that the aircraft departed from runway 28 at Statesville Regional Airport. They also confirmed that the aircraft was attempting to land back on runway 28 when the crash occurred. That means this was not an opposite direction return. The aircraft did not take off one way and attempt to land the other. It did not switch runways due to wind changes or traffic conflicts. It departed and attempted to return to the same runway. Why does that matter? Because when pilots change runways during an emergency return, it often introduces new variables: tailwinds, unfamiliar sight pictures, compressed patterns, or rushed decisions driven by changing conditions. In this case, those factors are largely removed from the equation. Investigators also confirmed that winds were calm at the time of the accident. With no meaningful wind component, either runway direction would have been operationally acceptable. So, runway choice itself does not appear to be the driving factor here. That shifts the focus away from runway selection and squarely toward geometry. Approach geometry is simply the 3-dimensional picture of where the airplane is relative to the runway. Its altitude, distance, speed, and alignment. When that geometry degrades, options disappear quickly. Witnesses reported that the aircraft was coming in very low. Physical evidence supports that. You don't strike approach lights and treetops nearly 1,800 feet before the runway unless the airplane is well below a normal glide path. This raises a key question, and it's one investigators will be asking very carefully. How did the aircraft end up that low, that early in the approach? Was the descent intentional, an attempt to stay visual under a lowering ceiling? Was the airplane configured or managed in a way that made altitude recovery difficult? Was the crew trying to salvage an approach that was already outside normal parameters? Those are not conclusions, they are lines of inquiry, and they matter because once an aircraft is low and close to the runway, there is very little time left to fix small errors. Approach stabilization isn't an abstract concept. It's about predictability, stable speed, stable descent rate, stable alignment. When any one of those slips, pilots usually rely on altitude to buy time. When altitude is already gone, time goes with it. At this point in the briefing, the NTSB made it clear they are not assigning cause, but the geometry alone tells us something important. The challenge was not where the runway was or which direction it pointed. The challenge was whether the airplane was ever in a position from which a safe landing could realistically be completed. And that naturally leads to the next layer of the investigation, the environment the crew was operating in when all of this unfolded. Once runway geometry and flight path are understood, the next layer investigators turn to is the environment, and specifically, the weather the crew was dealing with during those final minutes. According to the NTSB, weather at the time of the accident met visual flight rules. Visibility was reported at 5 statute miles. Winds were calm. On paper, this was a legal VFR environment, but weather legality and operational margin are not the same thing. Ceilings were reported as broken at 1,200 feet and 2,200 feet with drizzle present. That combination matters. Broken layers at those altitudes don't necessarily block visibility outright, but they do interrupt it. They reduce contrast. They soften edges. They make it harder to judge distance, height, and closure rate, especially near the ground. This is the kind of weather that doesn't announce itself as dangerous. It doesn't look dramatic on radar. It doesn't trigger immediate alarms. Instead, it quietly narrows the space pilots have to work with. Ask a simple question. How much vertical room do you really have if the ceiling is around 1,200 feet and you're trying to return to land immediately after takeoff? Not much. In situations like this, crews often feel pressure, sometimes subtle, sometimes intense, to stay visual. Climbing into the clouds means committing to instruments, adding complexity at a moment when something else has already gone wrong. Staying below the ceiling feels simpler, more direct, but it comes at a cost. Altitude is time. Altitude is options. When ceilings are low and the decision is made to remain visual, the entire approach gets compressed vertically. Patterns tighten. Descent rates increase. There's less room to stabilize before reaching obstacles that normally sit well below a standard glide path. The NTSB specifically noted that weather is one of the 3 main pillars they will be examining, alongside the aircraft and the people operating it. That tells us investigators see weather not as a headline cause, but as a contributing context, something that shapes decisions rather than dictates them. And this is where the term VFR trap often comes up, not as a judgment, but as a description. Conditions are legal. Visibility technically meets the requirement, but the visual cues pilots rely on are degraded just enough to make precision flying much harder, especially close to the ground. Drizzle reduces contrast. Broken layers create uneven lighting. The runway environment can blend into the surrounding terrain, and if you're already low and close, small errors in judgment can become unrecoverable very quickly. None of that proves what happened here, but it explains why investigators take this type of weather very seriously, particularly when combined with a rapid return and a low approach. And ultimately, understanding how the crew perceived this environment will depend less on weather reports and more on what was happening inside the cockpit. At this stage of the investigation, the focus is beginning to shift away from external facts that can be measured easily and toward internal factors that take time to understand. The NTSB confirmed that the cockpit voice recorder has been located and recovered. It is now being sent to Washington for analysis. This aircraft did not have a flight data recorder, and it was not required to have one. That means investigators will not have direct recordings of control inputs, pitch angles, or airspeed from onboard systems. Instead, they will rely on a combination of radar data, ADS-B tracking, physical evidence, and, critically, what the CVR reveals. The cockpit voice recorder doesn't just capture conversation. It captures workload. It captures tone. It captures how tasks are divided, how problems are discussed, and how time pressure builds. Investigators will be listening for when the decision to return was made, what prompted it, and how that decision evolved as the aircraft got closer to the ground. They'll be listening for checklist usage, call-outs, confusion, or silence. Sometimes what isn't said is just as important as what is. The NTSB also confirmed there was no known Mayday call. That doesn't mean the crew wasn't dealing with a serious situation. It may simply mean there wasn't time or that attention was focused elsewhere. But it reinforces how quickly this sequence unfolded. Another important detail from the briefing is that 3 occupants on board held pilot certificates. Investigators have not yet been able to verify who was flying the aircraft at the time of the accident. The Citation 550 can be operated single pilot with a waiver or with a 2-pilot crew. That flexibility is common in business aviation, but it also means investigators will need to understand crew roles very clearly. Who was the pilot flying? Who was monitoring? How were responsibilities divided once the plan changed? In abnormal situations, role clarity becomes critical. If roles blur, tasks can overlap or be missed. Again, this is not speculation, it's simply why investigators place so much weight on cockpit coordination. At this point, the NTSB has not verified any mechanical failure. They have seen reports in the media, but none have been confirmed. Both engines were recovered with the main wreckage, and all major flight control components have been identified. That doesn't rule anything out. It simply means investigators are proceeding methodically, not jumping ahead of the evidence. They are also continuing to collect witness statements, video footage, and audio recordings from the ground. These can help establish aircraft height, attitude, and trajectory in ways that data alone cannot. Put simply, the investigation is now moving from the outside in. The physical path of the aircraft is becoming clearer. The environment it was operating in is better defined. What remains is understanding how the crew perceived their situation in real time, what they knew, what they believed, and what options they thought they had left. This briefing does not answer every question. It isn't meant to. It marks the transition from early uncertainty to structured investigation. What it does give us is clarity on what this accident was and what it was not, and it shows us where investigators are now focusing their attention. As more verified information becomes available, especially from the cockpit voice recorder, we'll return to this case and walk through what it tells us, carefully, responsibly, and grounded in evidence. Thanks for watching, take care, and see you in the next video.